Okay, hi, what's up guys? My name is Hannah Zermino, and today I'm going to be giving you an informative speech about how math is involved in one of my favorite hobbies. So let's get right to it. Did you know that math is all around us? Literally every day, and I know everybody says that, but how well do you know and recognize it? So one way that I use math every day is in my baking, and without it, I swear my dishes would be just shy of awful. So today I'm going to talk about how deeply connected baking is to math. Some main points we're going to talk about are measurements, what we know and how we know it, multiplying and dividing fractions to account for more or less when preparing dishes, converting a recipe from Celsius to Fahrenheit, super important, and if you don't know how to do it, you're totally going to blow it. So let's talk about food, right? We all love food, who doesn't? Even if you're not a chef, we can all at least appreciate a fantastic dish. But how often do you consider what it took to create that perfectly seasoned and baked dish? It's a lot more than love in mom's recipe. It's about skill and lots of math. Without measurements for ingredients and multiplication for size and conversion for baking heat, all those dishes we love would essentially really suck. So let's get right into it with main point 1. Let's talk about the more obvious of the mathematical elements used in cooking, measurements. Thankfully, we have teaspoons and tablespoons and cups on racks with measurements we need already written down for us. But what if we didn't have those things? That's where math comes in. In order to convert measurements, you have to know and understand the following. And I'm going to read these out to you guys, but I also want to flip it so that you can see. Alrighty, so with 1 tablespoon, that's going to be equivalent to 3 teaspoons and 15 milliliters. 4 tablespoons is 1/4 cup, 60 milliliters, and 1 ounce is 2 tablespoons, 30 milliliters. Now we're going to get into a little bit of bigger measurements here. 1 cup, 8 ounces, 1 pint, 2 cups, 500 milliliters, 1 quart is 4 cups, 950 milliliters, 1 quart is 2 pints, 950 milliliters. Notice how those two stayed the same, and that middle one, conversions are tricky like that. 1 gallon is 4 quarts, 3,800 milliliters, and 3.8 liters. So a lot of this is decimal moving as well, which is the easier portion of this math. With the help of these guys, conversions are a piece of cake. So let's give an example. Something we all use and we're familiar with is rice. What are the conversion equivalents for making yourself or your family some rice? 1 cup uncooked rice is going to yield 3 cups of cooked white rice. 1 cup brown whole grain rice is going to yield 4 cups of cooked brown rice. And I want to point out that it's different with the different kinds of rice, and dishes are going to be like that as well. So you're going to have different measurements for different kinds of food. It's tricky. So basically when it comes to rice, less is more, but you wouldn't think that just by eyeballing it because it really does look like a little bit. Now it's not just measuring that comes in handy. Multiplying and dividing fractions to account for more or less is pretty much an everyday thing when it comes to the kitchen. Multiplying and dividing comes in handy even when cooking for all kinds of things. Baking, timing, and most importantly, serving sizes. Having too much or too little of something is a great way to test yourself or guests. So say you have a recipe, the dish is up enough for 5, but you want to just feed yourself. That's where the math comes in. If the recipe serves 4, cut everything in half. If it serves 6, reduce everything by 2/3, and so on. See, the thing is, measuring cups are great, but to have an understanding of math is better. Now, I mentioned conversions before, but it's not just used for measuring. Conversions are necessary in all kinds of environments and for all kinds of reasons. Something especially important for cooking is temperature conversion. God forbid the hot food comes out cold. Conversions are tricky, no denying, and if done all wrong, all sorts of things can fall apart. When converting Celsius to Fahrenheit, there are a few things to keep in mind. As this is arguably the harder of conversions, let's start, since both Celsius and Fahrenheit scales are offset, i.e. neither are defined at starting at 0, so it's tricky. Every additional unit of heat energy the Celsius Fahrenheit scales add a different additional value. Okay, so I'm going to go through that again because I feel like that sounded a little choppy. So both Celsius and Fahrenheit, they add a different additional value, and neither of them are defined as starting at 0. So when you're getting a value, you're not gonna get a 0 value or a max, like extreme value. You're gonna get somewhere in the middle. Every additional unit of heat energy the Celsius and Fahrenheit scales add a different additional value. Because of this setup, it's impossible to say that doubling the C or F value doubles the amount of heat energy. So it's difficult to get an intuitive grasp of how much energy 1 degree Fahrenheit or Celsius actually is. So the process relies heavily on the following formula. So Fahrenheit, Celsius, you're going to have 1.8000 plus 32 degrees. I'm going to see if I can show that closer to you guys. Yeah, okay. So basically, the simplest way I can put for dealing with conversions is they give you an equation, and you're going to want to follow that equation to the T. It's actually not very difficult. It's a super simple addition equation. Easy peasy. Now to get into some easier stuff when converting Fahrenheit to Celsius, we are in calmer waters, as this is territory we are used to. When converting this way, you simply need to take 30 off the Fahrenheit value and then half that number. So this is when we're talking about Fahrenheit to Celsius. Previously, we were talking about Celsius to Fahrenheit, and that's the more complicated one because we're not used to that even in our general area. When we're measuring temperature, we're typically not going Celsius to Fahrenheit. So with this one, this is a lot easier for us because this is more common. So, like I was saying, when converting this way, you simply need to take 30 off the Fahrenheit value and then half that number. Without these conversions, much of the food we love wouldn't be the same. So again, it's a simple equation. It's kind of just reversed. Now, I think you get the point here. Cooking takes a lot more than passion because at the heart of it, as with most things, is math. So, now you see how quickly things can heat up in the kitchen, and I mean that literally. It's harder than we think and requires a little bit of math to get the finished product. In this speech, I explained how necessary conversions are for the measurements and baking, and how multiplication and division is the tool used for table servings. Without math, we would be lost, and much of the food we know and love would be tasteless, cold, and lacking. But thankfully, that isn't so because math is involved in everything. And without it, and without these equations, we would not be getting the fulfillment